Okay, so let's talk about exception handling. Now, I've got a GUI class here, which has got some GUI components and some buttons, so some input text fields and some buttons, and we're going to store data in a linked list of student email objects. And here's a constructor which is building my GUI, adding the labels and text fields to panels, adding the buttons to panels, adding the panels to grid, and adding the components to the user interface, activating the buttons so they're clickable. Things happen when the user clicks on them. I've got a method that checks if a student ID is already in the linked list. I've got an add student method which gets the user inputs, creates a new student email object, and adds them to the linked list. I've got a delete student which checks if a student is, and we're deleting them by ID, so I'm checking if the given ID in the text field is in the linked list, and if it is, then we can remove them from the linked list. And a display all to display all students, an exit application, and a main. So pretty simple stuff. And over here I've got the student email class. It's just got two data items to keep it simple. A default constructor, a parameterized constructor, and accessor methods, the get name and get ID, and the mutator methods, set name and set ID, and a toString method. So very simple stuff. You would have developed classes like this many times already this term, and so simple GUI and a simple data class. So where does the validation go? Okay, so we're going to talk about validation of user inputs. So when the user clicks add student, which is what happens when the add button is clicked, the add student method is fired off. So that's this code down here. Okay, so we don't want to just add any old nonsense into the linked list. We want to keep our data validated. So how do we do the validation? Should we do it here in the GUI, or should we do it here in the data class? Now the data class owns the data. That's where the data lives. So the validation is going to go anywhere. It should go in the data class. Okay, so you shouldn't really be doing any validation of inputs here in the GUI class. You should be doing it in the data class. And there's a big advantage of doing that as well. So if another project reuses your data class in the future, it gets all the validation for free. Okay, so you don't want to be duplicating validation every time we move it around to another project, because you want to make sure the same validation rules are being enforced. Okay, so theoretically, anything that changes class data should validate it. So the parameterized constructor should do validation before it does. Sets the class data name equal to the name passed in and the ID equal to the one that's passed in. It should do validation before it does that. And also the set name should validate the name, and the set ID should validate the ID. Okay, so we don't want to duplicate things, and we want to keep the validation rules as close to the data as possible, and that means in the class that owns the data. So the validation should go here in the student email class. Okay, so let's look at adding some validation. So we could do just simple stuff like name. We want to delete the leading and trailing spaces from the name that's passed in. So we can call the trim method. Same for ID. Oops. ID.trim. And that's removing leading and trailing spaces, tabs. Okay, so we're going to clean things up before we do any processing on it. Okay, now we can do a check if the name passed in is blank, so you can do a dot compare to. Okay, so if the name is blank, or you can do it even more simply, you can do dot length is equal to 0. That's even shorter again. So if the length of the name is 0, what do we want to do? Okay, and what we could do, let's just do a simple message dialog for now. Okay, so J option pane dot show message dialog, null, error, name cannot be blank. Okay, and then we're going to validate the ID. And I'm going to do it the bad way to start off with. Okay, ID cannot be blank. Okay, so I've just changed the error message here. So name cannot be blank or ID cannot be blank. Okay, so if the name is blank, we get that error message. If the ID is blank, we get that error message. Now the bad thing about this is that if there's multiple errors in the input data, we could be validating lots of things. We'll pop up an error for that dialog, we'll pop up another dialog for that error, and we'll keep popping up dialogues to the user, and that will drive the user crazy. So we just want to pop up one dialog if there's an error, the very first error message, and then stop processing, do nothing more. Okay, so let's do that. So it should be an else if. Okay, so if the name is blank, display a name error. If the ID is blank, display an ID error. Okay, and we only want to do this processing down here if all the validation checks are passed. So right at the end of your validation, you'll have if, else if, else if, else if, else if, else if, doing all your checks. And right at the bottom of that, there'll be an else. And that's when you'll say everything's okay. And we'll set our class data equal to the values that were passed in. So just put a little comment there. All is okay. Set class data to the values passed in. Okay. So we only want to do that if all the checks up above pass. So in other words, we don't enter that if test. The name wasn't blank, the ID wasn't blank, and any other validation steps we want that would go in there, they've all passed. None of the error dialogs have appeared, so then we can set our class data. Okay, so that's version 1. What's the problems with that? Okay, so the problem is, back in the main class, how do we tell back here if an error has occurred? Okay, how do we tell? We can't. We can't tell if any of the data fields are invalid or not, and we can't tell if an error message has been displayed or not. So that's issue number 1. Issue number 2 is we're making a lot of assumptions here about the application. We're assuming a message dialog will be appropriate. What if we're running in console mode? What if we're running in batch mode? What if we're running on a web server somewhere? Okay, in some of those cases, a message dialog will not be appropriate. Instead, it might be a more appropriate error message to put out to the console screen, or maybe to a log file for a database, or somewhere else. Okay, so the data class, our student email data class, it doesn't know what type of application it's being used in, so it shouldn't make assumptions about the application. So it should not show message dialogs. Okay, because that means we're stuck to running in a GUI basically. Okay, or else the error message will be appearing away from the application, which is bad as well. So we don't want to do that. That's bad, and we don't want to do that. That's bad. So those things are bad. So what can we do? Okay, now this is where exception handling comes in. So exception handling, what we can do for our data class is create our own exception types. And down here, when we get an error, we can throw that exception. And what we can do over here, if we get a name error, we can throw another exception. So we can just throw exceptions. In other words, create exceptions or raise exceptions when there's problems with the data. And back in our main program, or GUI program over here, we can catch those exceptions and take action, display an error message in a dialog, or however we want to display the message, in a label, or however we want to do it. Okay, so that's what it comes down to. So we need to create our own exception classes. It's thankfully very easy in Java, very easy. So we'll have a look at that. Okay, so let's just go back at the top of our class. So we're going to create another class, another public class, and it's going to be our exception class for dealing with student email class exceptions. Okay, so let's go new, or create a new file. Okay, public class, student email exception. And I'm going to save that as a Java file. .java. Okay, so there's our student email exception. We still need to do something up here. We're not finished yet. Okay. Now, when you create an exception class, you provide 4 types of constructors. Okay, a public constructor, just a default constructor, which takes no parameters, and you're just going to call a superclass constructor. Okay, and then we're going to create another one, which takes in a string. Oops. Control C, Control V. The second one takes in a string parameter, and it passes that to the superclass constructor. The third one takes a throwable object, and generally it's called cause, but you can call it whatever you like, and that's passed to the superclass constructor. And the fourth one takes a message and a throwable and passes both to the superclass constructor. Okay, and that's pretty well all the code is. Okay, so we've got 4 constructors, a default one and 3 parameterized ones. One takes a string, one takes a throwable, and one takes a string and a throwable. Okay, and just passes those bits of data up to the superclass. Okay, and that's basically how it works. Now here we need to write a little bit of code, extends, and we need to tell Java where to fit our exceptions into the Java error hierarchy. Okay. Okay, so here's the Java exception class hierarchy. Everything's descended from object, as always in Java. Object's always the parent, and then the ones we're interested in for exceptions are under the throwable. Okay, and there's several main branches. There's the error. Okay, and these are things like serious errors to do with the Java virtual machine errors and things like that. Generally, we can't recover from those. Okay, if they occur, generally we can't even catch them. Our program just crashes. Java crashes. Okay, so and restarts. Okay, so they're really problems or bugs in the Java language or the Java runtime environment that we can't do anything about. So we can't really do anything with errors. Okay, scrolling down further, and this is our next part of the hierarchy. We've got exception. Okay, and you'll see under exception, I've written little tags here. These are all checked exceptions. Okay, checked exceptions. And there's another branch of the exception hierarchy called runtime exception. And these are unchecked exceptions. Okay, so what do they mean? Checked exceptions, if you're writing any code that could raise any of those exceptions, you must either have a catch block that deals with the exception, catches the exception, or you must declare the exception as throwable in the method header. So you put a throws, for example, throws interrupted exception in your method header. Okay, so you must either catch interrupted exception or you must throw it, and then whatever calls your method must catch it or throw it back up, and it can somewhere up the hierarchy there's got to be a catch clause to deal with those exceptions. Okay, so checked exceptions means you must write code somewhere in your program to catch those exceptions. Then we've got the unchecked exceptions. Okay, and they're things like arithmetic exception, illegal argument exception, number format exception, array indexing exceptions, and all sorts of things like that. Now, any code that you write that might raise those exceptions, you can deal with or not as you see fit. You do not have to write try-catch for those unchecked exceptions. If you don't handle them, your program will crash. But Java doesn't force you to write the try-catch or to handle the exceptions. Okay, so that's the difference between checked and unchecked. Checked, if you want to use any code in Java, in the Java libraries that might raise any of those, you must write try-catch somewhere to handle those exceptions. And for the runtime exceptions, you can not handle them if you don't want to. You don't have to write any try-catches. Okay, so it just depends on what you're doing. All right, now a common rookie error when you're dealing with exception handling is you choose something that looks like it might be okay. For example, illegal argument exception. That sounds pretty fair. Okay, so let's make our exception class extend illegal argument exception. Now, as you recall from our discussion just then, illegal argument is under runtime exception, so it's unchecked. We do not have to write the try-catch code for it. Okay, so in our class now, instead of displaying a message, we're going to throw new student email exception, and we're just going to pass through that name, that string there as a parameter. Okay, and same down here, we're going to call that and say ID cannot be blank. Okay, so there's a big difference there. In the first one, we're displaying a dialog, okay, which we've commented out. Now when we get those errors, we're going to throw new student email exception and pass through a string, which is our error message. Okay, so now back in our GUI class, when we're creating a student email object, and we probably want to do that before we try and add it to the linked list. Okay, so we'll separate this out and we'll say, just change our code slightly. We'll create a new object, student email stud equals new student email, and pass through the name from the text field and the ID from the text field. And then we'll add that student object to our array list or linked list. Okay, but we'll do this in a try catch. Try catch, and we're catching a student email exception, and we only want to add it to the linked list if there are no exceptions. So we can do that after we create the object. Okay, so if any errors are detected inside the constructor when we're creating a new student email object, for example, here we've got a blank name, for example, an exception will be thrown. Okay, so command will stop after that, at that statement it'll stop, and it will go down here to the catch. Okay, so down here we can go J option pane dot show message dialog null, comma, and we'll get the error dot toString string. I'll get there eventually. Okay, so whatever our error object is here, our object of type student email exception, if we do a toString on that, we'll get the error message and details about the error. Okay, and we can just display that in the dialog for now. Okay, so let's see that in action. Okay, so just to recap, we've got our student email exception class, extends a legal argument exception, which is an unchecked exception. I want to show you why that's important in a second. Okay, and then we've got our GUI, which tries to create a student email object called stud with the details from the text fields, name text field, get text, ID text field, get text. So it's passing those details through to the student email constructor. And if everything's successful, there's no errors raised, the student will get added to the linked list. Okay. If there are problems with the data, for example, the name's blank or the ID's blank, an exception will be thrown, throw new student email exception, and we're going to pass through a string to that exception, and that string is going to get fed into this error here, this error object, and we can display it here with our error.toString. So it sounds a little bit complicated, but it's really quite simple. Once you've done these a couple of times, they're really quite simple. Okay, so we'll compile that, make sure it's okay. Yep. We'll compile this. We'll compile our data class first. Everything's fine. And then we'll compile our GUI. With an error there, I'm missing a semicolon on the end. Semicolon's missing there. Control 1, Control 2. Okay, now let's try and add a student with no data. Okay, student email exception, error, name cannot be blank. Let's put a name in. And then we get an ID cannot be blank. I click that again and an ID cannot be blank. So we're going to put in a student ID, 1, 2, 3, and I've got to type in my name again because it's lost all the details that were there before. Mike, add, and there, everything's added. Okay, so we can improve things slightly there. Let's now only reset the fields and only display them if things have changed. Okay, so we'll move that inside the try block as well. Okay, so the latest linked list will only be displayed if the student was created and it was added to the linked list, okay? And the input fields will only be reset if everything's been okay, if all the data's okay. So it's only if it's added to the linked list and everything was displayed, then we'll reset the fields. If there's any errors in the student creation and the exceptions thrown, our IDs, our inputs will stay intact, which is what we want. We don't want to be erasing inputs on the user when they've got to fix things. If they've got 15 inputs and we're erasing them on the user when they've got to try and fix things, it'll drive them crazy. They'll want to come and hurt us. Okay, Control 1, Control 2. Let's see if that's better. Okay, add. Okay, exception, good. Let's put in a name. Add. And you'll see this time I get the error message and my input stays intact, which is what I want. I don't want things being erased when I've got to enter them again. Let's enter an ID. Add. Everything's added okay. So you might think on the surface, that's working really well, but what if I take out the try catch? So I've taken the try out, and I'm going to comment out all this catch down to the end here. What happens if an exception's thrown? Okay, so I've got no try catch to deal with the exception now. The exception's of type illegal argument exception. Okay, so there's no catch anymore. I've commented it out. Control 1, Control 2. Sure, I'll leave the name blank as well. Add. Okay, and see what happens? Our program no longer catches it, and instead Java just crashes, or our program crashes with an ugly error message which you'd never want the user to see. Okay, so we're allowing anyone that uses our data class to not catch exceptions. And the reason is that a legal argument exception is an unchecked exception. It's part of runtime exception, and there are unchecked exceptions. People do not need to write try-catch statements to deal with those exceptions. They're optional, okay? Which means programmers might not do it, which means your GUI class might not do it, and it'll compile stuff fine without errors, but you won't be catching the errors. Your program will be crashing in a heap. Okay, so how can we fix this? Let's go back to our error hierarchy. So that's the rookie mistake a lot of programmers make, and I see this a lot on the internet, on Stack Overflow, and websites like that. People say, oh, if you just create your own exceptions under a legal argument exception or under runtime exception. That's wrong. As we've just shown, that's wrong because it's not mandatory to catch the exceptions. Okay, so a much better way, and for now we'll just tack them under exception. This is a checked exception area in Java. They've got to be checked. So we'll just extend the exception class for now. There are better places to put it, for example, under these regions here, but we'll just go with exception for now. Okay, so let's go back to our student email and we'll go extends exception. And just a little reminder here, these are checked. Okay, so if we write any code that might raise an exception or something that extends exception, we've got to put try catch. So let's compile this error class. Everything's okay. Let's compile our data class, and it'll say here unreported exception. Student email exception must be caught or declared to be thrown. So you must either put the try catch inside here, or you must declare the exception to be thrown. Okay, now we can't put the try catch in here because we don't know how to handle the error. Do we display a dialog? Do we display it in a label? Do we display the error in a console window? Where do we display the error? We don't know. All we can do is pass it back to our classes that use our data class. So here all we can say is that it throws, and I'll put it down on the next line just so it's easy to see. So it throws student email exception. Okay, so now we can compile. And Java's accepted that because we've declared that error to be thrown by that method, by our constructor. Let's now go and try and compile the GUI class. Now we've commented out our try catch. And you'll see Java's telling us unreported exception, student email exception. It must be caught or declared to be thrown again. Okay, so Java's forcing us to catch it. Here we're not. Here we've sort of run out of options. We've got to do the try catch here because this is the only place you can handle it. Okay, so try catch. We've put those back in. Control 1, Control 2. Add. Okay, cannot be blank, name cannot be blank, Mike, add, ID cannot be blank, S123, add, and there we go, everything's fine. Okay, so what did we learn here? We learnt that our data class should be the one that's raising exceptions or doing the data validation. Okay, so our data class, this data class here owns those fields. Okay, so it should be responsible for validating them as well. And so anywhere that changes class data, for example, here in a parameterized constructor, we're doing our validation for a name, and then we're doing our validation for ID. And if there was other data items or other rules, for example, name's got to be a certain length, or ID's got to start with a certain character, we do those here as well. Else if whatever else we've got to check, else if whatever else we've got to check. Okay, so we'll just be doing all these here as well. And if any of those failed, we can't show the message in the J option pane, because that's assuming we're running in a GUI, or that the user class that's using our data class wants to display the errors in a dialog. That might not be the case at all. They might want to display the errors in a label, or the console window, or in a log file, or somewhere else. So we cannot just show message dialog them. So really all we can do is throw them, okay, with a nice meaningful error message. So down here we'd have different throws. So if other rules are violated, for example, name must be 5 characters or more, and so on. So we could do all those sort of errors, and student ID's got to start with an S, so that could be another throw. Student ID must start with an S. We don't have any of those rules yet, so I'll take those out. I'm just showing you how things work. Okay, so we're throwing exceptions here, and we've got a student exception class which extends exception, and we did that because they're checked exceptions. Anything that uses our data class now is forced to handle those exceptions. We've got the 4 constructors, the default constructor, and the 3 parameterized constructors. They're really easy to set up. That's all the code you need. Okay, that's all the code you need. So for every data class you create, you'll create an exception class that goes along with it. And then in our GUI, because we're doing checked exceptions, we've had to put the try catch in to deal with those exceptions. And here we're displaying the errors in a dialog, but we might want to just, instead of doing that, we might want to just set a label. So my label dot set text error.toString. Okay, so if you don't want to show errors in a message dialog, you can show them in a label by doing that, or maybe you could write them to a log file. So you could create a file object and write the error to a log file as well, or you could do all 3. Okay, so it's really up to the user class, the class that's using the data class, how it wants to handle the exceptions. Display them in a dialog, write them to a label, write them to a log file, write them to the console window, or many or all of the above. It's up to the user class to do that. Okay, for me at the moment, I'm just going to keep them in a dialog. Okay, but that's the choice of my GUI. If I was writing a web application or a console application, I'd probably want to handle the errors differently. Probably not a dialog, maybe just write them to the console screen. Okay, so that's just the way it is. So that's doing validation the proper way. It's quite a long video, but really it comes down to something that's quite simple. Do your validation and throw exceptions. Extend the exception class or one of those other checked exception classes, and then you've got to do your try catch inside your GUI class or whatever class is making use of your data classes. Okay, hope that was useful. Thanks for watching.